Hey everyone, ready for some seriously cool science?
Always.
Well, today we're going to be talking about solar flares.
Oh,
But
nice.
not just regular solar flares.
hmm
We're talking about super flares.
Whoa, okay.
Yeah, they're these crazy, powerful bursts of energy from the
I
sun.
can imagine.
So, to get a sense of how much energy we're talking about, imagine all the energy the entire world uses in an entire year.
Okay, got it.
Now, picture a solar flare just unleashing that amount of energy in just a few hours.
That's wild.
And get this, recent research is actually changing how we view these super flares.
Really? How so?
Like their frequency and the potential risk they pose. It's pretty mind-blowing.
Yeah, it is. It really makes you appreciate the forces at play in the universe, doesn't it?
It really does. So we got this article that delves into the whole thing.
Kind of cool.
And what I found super interesting is that researchers weren't even looking for super flares when they stumbled upon this data.
Ah, okay. One of those happy scientific accidents.
Exactly. So today, we're going to break down this research, try to grasp its implications, and see how it changes everything we thought we knew about our very own sun.
Sounds like a plan.
So first things first, can you give us a little solar flares 101?
Sure. So at their core, solar flares are basically gigantic bursts of energy and radiation
Gotcha.
erupting from the sun's surface.
Oh.
Like massive explosions, just sending out waves of charged particles and magnetic fields shooting out into space.
Okay, and we've seen the effects of these before, right?
Oh, yeah,
Remember the Carrington Event back in 1859?
of course. That's like the textbook example.
Yeah, where the auroras were visible as far south as the Caribbean.
It's pretty incredible, actually.
Mhm.
The Carrington Event is a perfect illustration of how a powerful solar flare can impact Earth. Telegraph systems went haywire back then.
Right.
And those auroras you mentioned, they were a crazy sight to behold, but also a bit of a spooky reminder of the massive magnetic disruption happening all around us.
I bet. So that event, as intense as it was still considered a regular solar flare.
That's right.
And I read somewhere that a recent flare, the one in 2023, released energy equivalent to something like 10 billion Hiroshima bombs. That sounds pretty intense on its own.
Oh, yeah, it was definitely a big one. But now, imagine this. Super flares can be 100 times stronger, even stronger than the Carrington Event.
100 times.
Yeah, think about that. It's a mind-boggling amount of energy. Luckily, we haven't witnessed a super flare from our sun directly.
Oh, that's a relief.
But scientists have been studying them, though, indirectly. And that's where it gets really intriguing.
Okay, so where does NASA's Kepler Space Telescope fit into all of this? I thought Kepler was built to hunt for planets.
It was, yeah. Kepler's main mission was all about finding planets orbiting other stars.
Right.
But the way it does that, by looking for these tiny dips in a star's brightness when a planet passes in front of it, also made it super sensitive to detecting flares from those stars.
So basically, it was gathering data on flares by accident.
Pretty much.
Yeah.
It was this awesome unintended consequence. Kepler ended up with a mountain of data on stellar flares, including superflares.
That's amazing. So researchers were basically able to study superflares from a whole bunch of stars similar to our own.
Yeah, thousands of them.
And they found a specific pattern, right? Something called a power law distribution.
That's it. It's one of the key takeaways. A power law distribution basically tells us that smaller events, like those smaller flares, are way more common than bigger ones. But the important thing is it also shows us that while superflares might be rare, they're not as rare as we initially believed.
Okay, so it's kind of like you see a ton of pebbles on a beach, but finding a massive boulder, while it's less likely, it's not impossible.
Yeah, that's a great analogy.
Which leads to a pretty unsettling question. If superflares are more common than we thought, why haven't we, experienced one from our sun in recent times?
That's the million-dollar question, isn't it? Scientists are scratching their heads over that one. There are a couple of main theories floating around. One is that our sun is just going through a particularly calm phase, compared to other stars like it. The other possibility, which might be a bit more concerning, is that we've just been incredibly lucky so far.
Oh, wow.
It really gets you thinking.
It does. But let's get into the nitty-gritty of what a superflare could mean for us here on good old planet Earth. Right? We know it's not going to be just a pretty light show, right?
Oh, definitely not. The impact could be pretty severe, starting with what would happen in space. All those satellites we rely on
Yeah.
for communication, navigation, you name it, they could get fried by the intense radiation and electromagnetic pulses.
Oh, no. And then, if enough satellites are knocked out, we'd end up with that, what's it called? The Kessler syndrome?
Right, where space gets so jammed with debris from all those collisions that it becomes super dangerous, practically unusable.
Yikes. A cosmic traffic jam with incredibly high stakes.
Exactly. And that's just one part of the problem. We'll delve into the potential impact down here on Earth in the next part of our deep dive.
Okay, looking forward to that. But before we go there, I want to circle back to that graph in the article. The one comparing the old predictions about solar flare frequency with what this new research has found.
Right, that's a good one.
Yeah.
It really shows how much our understanding has shifted. The old predictions, based on what we knew about our sun, showed a much lower rate of big flares. But this new data from Kepler, it paints a completely different picture.
So it's like our sun has been hiding its true potential from us all this time.
Kind of, yeah. But, armed with this new information, we have a better grasp of the risks and a clearer call to action. We can't stop superflares from happening,
I guess not.
but we can prepare for them.
And that's exactly what we'll be exploring in more detail in part 2 of our dive. So stick around because we'll be getting into the potential fallout of a superflare hitting Earth, and most importantly, what steps we can take to lessen those risks. All right, welcome back to our deep dive into the world of superflares.
Glad to be back.
So before the break, we were discussing the havoc a superflare could create in space, right?
Yeah.
Like knocking out those satellites and causing a whole chain reaction of collisions. It's some pretty scary stuff when you think about it.
Oh, yeah, definitely. And, the effects wouldn't just be limited to space, unfortunately. A superflare could have some serious consequences here on Earth, too.
Yeah, that's what I wanted to get into. So what kind of damage are we talking about on the ground? Like what could actually happen?
Well, one of the biggest concerns is the impact on our power grids.
Hmm.
The massive electromagnetic pulse from a superflare could induce these huge currents in power lines,
Right.
and that could lead to widespread blackouts, potentially.
I remember reading about that solar storm back in 1989. Oh, yeah.
The one that caused that big blackout in Quebec.
Right.
And that was just like a minor solar storm.
Exactly. And if a minor storm could do that, imagine what a superflare could do. It could be way worse.
So how much worse are we talking about?
We could be looking at blackouts that last for months.
Months?
Yeah, across entire continents. Imagine the kind of disruption that would cause to, well, everything. Our daily lives, the economy, you name it.
It's kind of hard to wrap your head around. Everything runs on electricity these days. Hospitals, transportation, communication, it all depends on a stable power grid.
It really does. And that's not even taking into account the potential for damage to other types of infrastructure.
Oh, right. What else would be affected?
Well, pretty much anything you can think of. Pipelines, transportation systems, electronic devices, anything that's sensitive to electromagnetic interference.
Wow.
The economic cost alone could be, trillions of dollars. It's a really serious issue.
Yeah, no, it sounds pretty dire, but at least Earth has that magnetic field, right?
Right. That's kind of like our shield against solar radiation, isn't it?
Exactly. Our planet's magnetic field does provide a vital layer of protection. It deflects most of those charged particles that the sun throws our way.
Yeah.
But the thing is, a superflare is so incredibly powerful that it could potentially overwhelm even our magnetic defenses.
So even our natural shield might not be enough to handle a superflare.
Yeah, that's right. We might not be completely protected, which is a pretty sobering thought.
It is. You mentioned earlier that researchers are studying these superflares from other stars, right?
Yeah.
Does that mean there's any way to predict if one's going to happen on our own sun? Like, can we see it coming?
It's a great question. And it's actually a really active area of research right now. Scientists are working hard to develop better prediction models using all the data we're getting from Kepler and other telescopes.
Okay, so we're not totally flying blind then.
No, not completely. There's definitely hope that we'll be able to get some advance warning if the superflare's headed our way.
And that would be key, right?
Absolutely. Even having a few hours or maybe even a few days' notice could give us time to take steps to protect ourselves.
Yeah.
To try to minimize the damage.
That makes sense. So what can we actually do to prepare for a superflare? It's kind of like preparing for a hurricane, isn't it?
That's a good analogy.
Like, we can't stop it, but we can try to brace for impact.
Exactly. And there are things we can do, both in space and here on Earth.
Okay, well, let's start with space. What can we do to protect the satellites?
Well, for one, we can design satellites with better shielding, to help them withstand the radiation and electromagnetic pulses.
Okay.
And we can also use what's called safe mode.
Safe mode.
Yeah, it's basically a way to tear down the satellites during the most intense part of the storm to protect their sensitive components.
Oh, that makes sense. Okay, and what about on the ground? What can we do to protect the power grid?
Well, there are several strategies we can implement to make the grid more resilient. Things like installing surge protectors to absorb those huge currents, and strengthening transformers to make them less vulnerable to damage.
Okay.
And we can also design the grid with more redundancy, having backup systems and alternate routes for electricity to flow.
So it's kind of like reinforcing the weak points in the system so that it's less likely to have a cascading failure.
Yeah, exactly. And there's one other really important aspect to preparedness that sometimes gets overlooked.
Oh, what's that?
It's communication and public awareness. We need to make sure that people understand the risks posed by superflares
Right.
and that they have a plan in place for what to do in case there's a major power outage. It's not just about the technology, it's about people being prepared as well.
So it's a combination of technological solutions and individual and community preparedness.
Exactly. We need to be prepared on all fronts.
So to sum it up, we can't actually prevent superflares.
Unfortunately not.
But we can prepare for them, which is, well, it's kind of empowering when you think about it.
It is. It shows that even when we're facing these massive cosmic events, we're not totally helpless. We have the ability to understand them, learn from them, and adapt.
And that ties back to that point the article made about the philosophy of science, right?
Yes.
That science doesn't just teach us about the universe, but it makes us think about our place in it.
Yeah.
And how we should respond to things like superflares.
Absolutely. It forces us to think outside the box, to come up with creative solutions, and to work together as a global community.
Yeah.
Because this is a global challenge.
It really is. I mean, a superflare isn't just a scientific curiosity. It's a potential threat to our whole interconnected world. But it's also an opportunity, right?
It is.
An opportunity for us to come together, learn from each other, and build a more resilient future. And I think we've covered a lot in this part of our deep dive.
Yeah, I think so. We've explored what a superflare could do to Earth and talked about some of the things we can do to try to minimize the risks.
But there's still more to discuss. So in the final part of our deep dive, we're going to be talking about the latest research into superflares. And we'll touch on some of the ethical considerations of preparing for a potential global event.
Right.
And we'll also talk about what you, our listeners, can do to stay informed and get prepared. Welcome back to the show.
It's great to be here.
So we've spent this episode talking about superflares, right? These massive solar events.
Right.
And we've talked about what they could do both in space and here on Earth.
We have. It's pretty amazing and a bit scary when you think about the scale of it all.
It is. But in this last part, I want to shift gears a little and focus on what's being done to prepare,
Absolutely. Because while the idea of a superflare might feel kind of overwhelming, there are some real steps we can take to lessen the risks. Actually, even just researching and understanding these things is a big part of it.
Yeah, that makes sense. We can't really prepare for something we don't understand. So what were researchers focusing on right now? What's important?
Well, one of the most important things is getting better at predicting superflares. We can't say exactly when one might hit, but scientists are using data from telescopes like Kepler to develop models to, try to figure out the chances of a superflare happening on our sun.
So it's kind of like predicting earthquakes?
Yeah, kind of. We can't say exactly when, but we can identify areas of risk and try to develop some kind of early warning system.
Right. And even a little bit of warning could make a big difference, I bet.
Oh, absolutely. Even a few hours, or heck, even a few days' notice could give us time to power down important stuff.
Like what?
Like critical infrastructure and, put satellites into safe mode.
Oh, right. That would be super helpful. And that makes me think about something we talked about earlier, about how a superflare could cause all those blackouts.
Mm-hmm.
What about the long-term impact on our energy infrastructure, beyond just the immediate effects?
That's a great question, and it's something we really need to be thinking about, especially with how much we rely on electricity these days.
Right, everything's electric now.
It is. A superflare could really expose just how fragile our power grid is. But on the flip side, being aware of that fragility is actually pushing people to find new solutions.
Really? What? I'd love to hear more about those solutions.
Well, one thing people are exploring is creating power grids that are more, decentralized. Instead of relying on a few big power plants, we can create systems that use more distributed generation, like using solar and wind power, which would be less affected by these widespread disruptions.
Okay, so it's about spreading out the energy sources, right?
Exactly. Kind of like diversifying a portfolio, like you said before.
Right. And what about the grid itself? Can we actually make it tougher?
Yeah, definitely. We can use materials that are less likely to be affected by those electromagnetic pulses
Okay.
and install better surge protection, things like that. And we can design the grid with more redundancy, like I said before, so that if something fails, there's a backup ready to go.
So like a power grid that can automatically reroute electricity around a damaged area.
Ex-
That's amazing. So there's a lot of really cool stuff happening in that area, huh?
Oh, yeah, there's tons of cutting-edge research and development going on. But the thing is, all of these solutions require a lot of, investment and planning
Yeah, that makes sense.
and coordination.
Sure.
I mean, it really makes you realize that this isn't just a scientific problem, it's a social and political one, too.
It's a global problem.
It is.
Yeah.
To really prepare for a super flare, countries are going to have to work together.
That's a big ask.
It is. It requires long-term thinking
Hmm.
and, a willingness to invest in resilience.
Yeah. So we've talked about what scientists and governments can do,
Right.
but what about regular people, like our listeners?
Yeah.
Can we do anything to prepare for a super flare?
Luckily, yeah, there are things we can do. Even simple stuff like having an emergency kit ready with, food, water, essential supplies.
Okay, so the basics.
Exactly. And having a plan for communication, if the cell networks go down.
Yeah.
And knowing how to stay safe if the power's out for a long time.
It's like that saying, hope for the best, but prepare for the worst.
Exactly. And in this case, being prepared means understanding the risks, having a plan, and, being part of the community that can support each other.
And knowing where to get information.
Right.
Right.
Yes. Staying informed is key. There are places you can go to monitor space weather, kind of like checking the weather forecast.
I'll have to look into that. So big takeaways for everyone listening. Stay informed, have a plan, and don't panic. Knowledge is power, right?
It really is. And the more we learn about superflares, the better prepared we'll be if and when one happens.
So well said. Well, as we wrap up this episode, I have to say I'm kind of blown away by how powerful these cosmic events are.
Me too.
But I also feel a sense of hope, knowing that we can learn and adapt and innovate.
Absolutely.
It's a reminder that even when facing these huge events, we have the ability to act, to learn, and to build a more resilient future.
I think that's a great note to end on.
It is. So thank you all for joining us on this deep dive into the world of superflares. Until next time, keep looking up and keep learning.